good with that then. Okay. So we're kind of read through these. Again, they're going to make sense to you. And then here in a second, we're going to look at a diagram, and you're going to see if you can figure out which postulate would go with that. And again, it'll be pretty straightforward. So 2.1 is the 2-point postulate, which means through any 2 points, there exists exactly one line. You already know that, because how many points do you need to make a line? 2. So that's obvious, right? And then 2.2 says the reverse. A line contains at least 2 points. You already know that as well. So the example says through points A and B, there's exactly one line, L. And line L contains at least 2 points. So it says the reverse. Questions on that? Make sense? See how much you've already learned? All right. 2.3. Line intersection postulate. If 2 lines intersect, then their intersection is exactly 1 point. Does that make sense? You already know that? Yeah? So, can you describe what's happening in that example, even though it's right next to it, so don't read it?
M and N, line M and N are intersecting and making point C.
At point C, but yeah. Line M and line N right there intersect at point C. So that's their intersection point. Good job. Okay. 2.4 is the 3-point postulate, which says through any 3 non-collinear points, there exists exactly one plane. You know that. How many points does it take to make a plane? 3. And that's how many we use to name it. And then the reverse is true. A plane contains at least 3 non-collinear points. Do you remember about, like if you have a line in the plane, remember that you can have 2 points on the line and 1 off, but they just all 3 can't be on the line. But you can have 2 of them on the line. Do you remember that? So you can have 2 collinear and just 1 somewhere else off of that line. So the diagram, through points D, E, and F, there's exactly one plane R, and then plane R contains 3 non-collinear points D, E, and F. All right, so just the reverse. Any questions on that? Is this coming back to you? Do you remember all of this like it was yesterday? Pretty much. I know. All right, 2.6 is the plane line postulate. If 2 points lie in a plane, then the line containing them lies in the plane. That, right? I mean, you can't have the line outside of the plane if the points. Yeah, it is. It is. But try and think about if you were learning this at the beginning of the year, right after you learned all that. It might not be as smooth. But points D and E line in plane R, so the line that is made by D and E are also, or is also in the plane. Last one is the plane intersection postulate. If 2 planes intersect, then their intersection is a line. So similar to 2 lines intersecting at 1 point, a plane and a plane intersect at 1 line. Okay? So the intersection of plane S and plane T is that line L. Okay? Where they're crossing is at that line. Oh, yeah. I know. Okay. Any concerns so far? All right. Well, let's use them. Could you state a postulate that we just looked at that describes what's happening in these 2 diagrams? In this if-then statement. Do you know what's being said?
If we have to name it.
Could you tell me what's happening right here? Okay. Huh? Yeah. So if 2 lines intersect, then
There should be a point where they intersect.
right, there should be a point where they intersect. And it's kind of hard to see on yours because it's not a colored print, but there's a red point where those 2 lines are intersecting. So what postulate did we just look at or read about?
Line intersection postulate.
The line intersection postulate. So that's the postulate, and you could say, it says you're explaining why, but that postulate does explain why. If 2 lines intersect, then they intersect at exactly 1 point, and that's what's happening in the diagram. So we would just want to say 2.3 line intersection postulate. Okay. Okay, look at the next one. Can somebody explain to me what's happening? What this if-then statement is stating? Maybe that hasn't said it, so not you. And you kind of helped last time. Anybody else? Besides Easton and Emerson? Plane intersection postulate?
If two planes intersect, there has to be a line intersection.
Okay, and that's what's happening. If two planes are intersecting, then they intersect at one line. Good. So we'd say 2.6 plane line postulate.
2.7.
Is it 2.7?
Yeah.
Whoops.
One is right.
Good call. Well, I was just trying to remember it all by myself. I didn't look at it. Yeah. And it's not like important that you remember the number exactly. Like, I need to remember in my brain 2.7 is exactly this. It's just that when we're going through improving things, we're not going to start like regular proofs until next week. We're going to look at algebraic proofs tomorrow and Thursday. But it's just important when we're going through that you remember, like, if I'm trying to prove this, I can say that this is true because I know that there's a rule about that. Like, if I've got two planes intersecting, then I know that they intersect at one line, and I know that because of this postulate. So it's just for recall mostly, that you know that there's a rule about this that you can use to back up and support whatever you're trying to prove later. So you don't have to memorize 2.7. Okay? Hutch, wake up.
I'm awake.
Are you? Okay, use the diagram to write examples of the plane point postulate and the plane line postulate. So that's, let's see. Plane point is 2.5 and plane line is 2.6. So we want to see if we can find things in this diagram that describe what those postulates describe. So 2.5 says what?
Plane contains at least 3 non-collinear points.
Okay, how many planes are in this diagram that you see? Two. Two clearly defined. Do you see one of the planes that clearly shows 3 non-collinear points?
A, B, C,
Are in plane
P.
P. So write that. Plane P contains A, B, and C. See if you can do 2.6 on your own. 2.6 says, if 2 points lie in a plane, then the line containing them lies in the plane. See if you can find a specific example for that postulate. Okay? Everybody get that? It sounds like I'm supposed to say. Okay. Sketch a diagram showing line TV intersecting segment PQ at point W so that segment TW is congruent to segment WV. Can you draw that on your own? Do you know what it's asking? Can you break it down? I'm going to give you a second, and then we'll see if we get the same thing. What can you tell me about placement for this intersection going on?
It's gotta be
Right, right. W has to be right in the middle. If we didn't have that TW was congruent to WV, you could just draw that intersection anywhere. But when we read that, we know that it needs to be right in the middle because this piece has to be congruent to this piece. Did you show congruency with those tick marks? Good. Some people last hour asked if it was okay if they drew it like diagonally, so kind of like an X. That's fine. Yep, that's fine. As long as what they're asking is actually being reflected, then that's fine. All right, good. Which of the following statements cannot be assumed from the diagram, or can be? So we're going to go through, if it can be assumed, we'll write yes. If it cannot be assumed, we'll write no. So can it be assumed from the diagram that points A, B, and F are collinear?
Yes.
Yeah, they're all on the same line. A, B, and F are all on this line. We can see that from the diagram. What about E, B, and D?
No.
No. There's not a line clearly drawn through them to assume that. They could be. We just can't assume from the diagram. Can we assume that AB is perpendicular to plane S?
Yes.
Yes?
Yes, because it has that little blue.
Yeah, there's a 90. So yes. What about CD? Can we assume it's perpendicular to plane T? No, not from this diagram. AF intersects BC at point B?
Yes.
Yeah, we can assume that. AF and BC intersect at that point B. Okay,